Welcome everyone. It's a pleasure to have you here for this informative session on the latest features in Amazon RDS for Oracle. Our objective for this session is to share valuable insights into the new features of Amazon RDS for Oracle, helping you stay up to date with them. To introduce ourselves, my name is Javed Mohammed and I'm a database specialist solutions architect at Amazon. With me today is my colleague Vishal Patil. I will let him introduce himself before we begin the session.
Thank you, Javed. Hello, everyone. My name is Vishal Patil. I'm a database specialist solutions architect at Amazon. Over to you, Javed.
Thank you, Vishal. So without further ado, let's dive right in and explore what's new in RDS Oracle. Our agenda for this session is overview of Amazon RDS. Then we will talk about new features including version support, new instance types, new options around data movement, multi-tenant, and at the end, we will touch upon other notable new features. Let's get started with overview on Amazon RDS. Amazon Relational Database Service (RDS) was built by AWS as a way to help customers reduce the complexity in supporting critical transactional applications by making it easy to set up, operate, and scale a relational database in the cloud. RDS automates time-consuming administration tasks such as hardware provisioning, database setup, patching, and backups while providing cost-efficient and resizable capacity. It frees customer to focus on their applications so that they can achieve the fast performance, high availability, security, and compatibility they need. RDS is currently offered for 6 familiar database engines: Amazon Aurora, with compatible with MySQL and PostgreSQL, and then we have MySQL, PostgreSQL, MariaDB, SQL Server, and Oracle. In a nutshell, RDS provides customer with lower total cost of ownership, easier management, that lets them focus on the things that matter for their business and applications. Let's dive into new features for RDS Oracle, starting with version support. The two major versions that RDS Oracle currently supports are 19C and 21C. Since 12C has been deprecated, customers will no longer be able to run 12C instances on RDS Oracle. We only support the versions of Oracle database that Oracle is providing support for. Meaning, when Oracle stops providing patches, we require customers to move to the newer versions that they are providing patches for. 19C here is a current long-term support release, and support is available through April 30th, 2024 without extended support or an unlimited license agreement. And support is available through April 30th, 2027 with extended support or an unlimited license agreement. 21C is an innovation release and it does have a much shorter support timeline. 21C only supports multi-tenant architecture. Oracle has announced support for 21C until April 30th, 2024. RDS for Oracle major versions remain available for at least until the end of support date for the corresponding Oracle database release version. Before we ask that you upgrade to a new major version, and to help you plan, we provide reminder at least 12 months in advance. We do so to communicate the detailed upgrade process. We follow Oracle support as listed in this note 742060.1 for the dates indicated. If Oracle makes any changes to these dates, we will adjust our deprecation plans accordingly. If Amazon extends support for an RDS Oracle version beyond the original timeline, we will update our support timelines to reflect the newer, later date, which can be found in our RDS Oracle documentation. For minor versions, we come out with a new minor version each quarter based on the release update, and this will also include Oracle patches as well as few custom patches that are covered in our documentation. With that, let's take a look at new instance types supported by RDS for Oracle. Because Oracle is commercially licensed database software and number of licenses needed depends on the number of vCPUs, we want to minimize and optimize those vCPUs to the number that we need. And generally speaking, we want to minimize the size of instance to the workload that we need because we have the flexibility to scale up and down at any time with minimal downtime. RDS for Oracle supports almost 100 instance types with various configurations. We are not going to go through the full list of instance types that we support, but we have launched quite a few new instance types recently. In a broad sense, we support three major families. There's the bustable, There's the general purpose, which is just kind of a good blend of memory and vCPUs. And then a lot of customers run their critical database workloads on our memory optimized instances, which have more memory per vCPU. Some of the notable ones are M6i and M5D in general purpose and R6i and R5D in memory optimized. M6i instances are the 6th generation of Amazon EC2 x86 based general purpose compute instances designed to provide a balance of compute, memory, storage, and network resources. R6i instances are the 6th generation of Amazon EC2 memory optimized instances designed for memory intensive workloads. M6i and R6i instances provide a new instance size of 32x large with 128 vCPUs and 33% more memory than the largest M5 and R5 instances. They also provide up to 20% higher memory bandwidth per vCPU compared to the previous 5th generation instances. These instances gives customer up to 50 gigabits per second of networking speed and 40 gigabits per second of bandwidth to the Amazon Elastic Block Store, 2x that of M5 and R5 instances. Both M6i and R6i instances are built on the AWS Nitro system, a combination of dedicated hardware and lightweight hypervisor, which delivers practically all of the compute and memory resources of the host hardware to your instances. D variant instances like M5D and R5D now support the instance store for temporary table spaces and database smart flash cache. These instances are ideal fit for applications that need access to high speed, low latency, local storage, including those that need temporary storage of data for scratch space, temporary files, and caches. You can now place the temporary table space in the instance store. A database session can write temporary intermediate data to a temporary table space and then read the data back into memory for processing. This strategy improves throughput for sorts, hash aggregations, high load joins, and much more. Furthermore, you can also configure a flash cache in the instance store. The flash cache works well for read-intensive workloads that use mostly single block random reads. Without the flash cache, queries read data from EBS storage, which has a higher latency than the local storage. With the flash cache, queries can read data blocks from the cache, which improves performance. The flash cache is available in Oracle Database Enterprise Edition. RDS for Oracle also supports memory optimized X2IDN, X2IEDN, and X2IEZN instances designed to deliver fast performance for workloads that process large datasets in memory. These are big beefy boxes. These support up to 4 terabytes of RAM and 128 vCPUs. These instances provide up to 32:1 ratio of memory to vCPU. With higher memory to vCPU configuration, you can optimize on licensing cost. On the next slide, we will look into new features for data movement for Amazon RDS Oracle. Here we'll talk about new option of EFS integration with Amazon RDS for Oracle. There are several options for data movement into RDS for Oracle instance. We can move the data from source to target database, that is RDS instance, using different ways like DB links over the network, logical replication using tools like DMS or Golden Gate, bulk load using data pump, etc. We typically use data pump with S3 integration option. However, there are a couple of challenges associated with this approach. One, there are a lot of steps. You have to copy dump file to S3 and then download it to RDS Oracle instance before importing it. The second challenge here is these dump files take up space. Let's say you have 1 terabyte dump file, you need to load it into your instance. You might need to create a 2 terabyte instance, stage that 1 terabyte dump file and load it into a terabyte of table spaces, drop that 1 terabyte dump file, and now we have a terabyte of space that we cannot reuse immediately. And also we cannot shrink the allocated storage in RDS Oracle. When you get to the larger sizes, especially VLDB migration, it can really add up and customers end up paying for the storage that might grow over time, but paying it for it starting today. EFS integration with RDS comes into picture here to overcome these two challenges. With EFS integration, we can stage transitory files like Oracle Data Pump export files on EFS file system and directly import from it. You can also leverage EFS integration for sharing a file system between RDS Oracle DB instance at an application instance or across multiple RDS Oracle DB instances to address your application architecture needs. Faster migration of data as compared to migration over database link. You can use Amazon EFS file system mounted on Amazon RDS for Oracle database instance as a landing zone for various Oracle files required for migration or data transfer. Using it as a landing zone helps to save the allocation of extra storage space on the Amazon RDS instance to hold the files. The Amazon EFS file system can automatically scale from gigabytes to petabytes of data without needing to provision storage. There are no minimum fees or setup costs, you pay only for what you use. Amazon EFS is designed for 11 nines of durability and 4 nines of availability. Now, I will hand over to Vishal to discuss about the other new features.
Thank you, Javed. Before we start with DataGuard switchover, let's talk about RDS replicas. We have had replicas for a few years now. We came out with in-region replicas first and then the cross-region replicas. We can have up to 5 total replicas per source instance, and they can be in the same region or different regions than the source instance. Historically, we have supported replica promotion during actual disaster recovery event or for DR drills. For example, if we have a replica and when we promote a replica, replication is terminated and standby is converted to a standalone primary instance, which is open for read-write access so that applications can reconnect to it. There are a couple of caveats with replica promotion. One, full backup is triggered to ensure durability, and we may not be able to make certain API calls until this backup finishes. And the backup itself can take up to a few hours for very large databases. Secondly, the other challenge is that this is now its own standalone instance. It has been opened with reset logs, so it has broken off from the original primary instance and any of its replicas. So now it cannot get back into replication with the earlier replicas. So if you do a replica promotion, perhaps during a DR situation or for a DR drill, what you will need to do is recreate replicas for this instance that allows us to maintain the original DR configuration. There is a little bit of heavy lifting to do there with replica promotion. A couple of things that have been launched recently to address these challenges are: one is automated and manual DB snapshots of RDS for Oracle replicas, which means you can have those backups running on a daily basis on replicas, or at least one replica that you might want to use for failover purposes. With these automated backups in place during promotion or a switchover, and that next backup that gets triggered right afterwards is going to be a fast incremental backup, which reduces the time spent during taking backups following a role transition. Furthermore, you can create a new database instance by restoring from such DB snapshot or perform point-in-time recovery. We also have launched Managed Oracle DataGuard Switchover, which enhances the customer experience by simply reversing the roles of the databases with no data loss and a brief outage without having to recreate the replicas. There are other benefits, like you can use this feature for performing disaster recovery readiness drills. You can proactively move the right workloads to another region in anticipation of a disaster. You can shift traffic regionally and follow the sun model you can use. It also allows you to maintain replication configuration after the transition. Also perform planned maintenance on the primary environment. You can shift traffic to a different instance or region during planned maintenance windows on the primary environment. Although this feature may be used for the purpose of disaster recovery exercises, that means tests that applications can reconnect to the new primary without risking data loss. This operation is not available in the case of a real event where primary goes down. In such scenario, we still recommend promoting read replica until the DG failover, that is DataGuard failover, is supported. In the next slide, we will look into some other notable features released recently for RDS for Oracle. In manageability, We have support for IPv6, Oracle Apex version 22.1, and now we can copy option groups while doing in-region cross-account snapshot copies. In performance and scalability, there is now provision to increase storage size when creating read replicas and restoring databases from snapshots. Also, now we support GP3 EBS storage type. By using general purpose SSD GP3 storage volumes, you can customize storage performance independently of storage capacity. Storage performance is the combination of I/O operations per second, that is IOPS, and how fast the storage volume can perform reads and writes, that is storage throughput. On GP3 storage volumes for RDS Oracle, Amazon RDS provides a baseline storage performance of 3000 IOPS and 125 megabytes per second for storage allocation less than 200 gigabytes. For storage allocation over 200 gigabytes, you get 12,000 IOPS and 500 megabytes per second as throughput as baseline performance. Under security and compliance, the new features are there are additional cipher suites available for OEM agent and SSL option. We also have January 2023 release update available for 19C and 21C instances. Next, database activity streams, which provides a near real-time stream of database activities to help meet your relational database for compliance and regulatory requirements. Now the DAS feature for RDS for Oracle is available in 3 additional regions that are Spain in Europe, UAE in Middle East, and Hyderabad in Asia Pacific. Lastly, for Oracle Native Network Encryption, NNE, to allow customers to block older ciphers and algorithms from being used by the SQLnet encryption and checksum, you can configure SQLnet.ora parameters. Those are allow, weak, crypto, server, or client. Both these parameters are true by default, but now they can be changed to false. In the next section, we will learn about new features released recently for RDS Custom for Oracle. Amazon Relational Database Service, Amazon RDS Custom for Oracle, is a managed service for legacy, custom, and packaged applications that require access to the underlying operating system and database environment. RDS Custom for Oracle now supports the Oracle multi-tenant option on Oracle Database version 19C using Enterprise Edition. With this release, the Amazon RDS Custom for Oracle Database instance can operate as a multi-tenant container database, that is CDB, hosting one or more pluggable databases, that is PDBs. A PDB is a set of schemas, schema objects, and non-schema objects that logically appear to a client as a non-CDB. Despite being consolidated in a single CDB, each PDB is isolated from noisy neighbors as well as from a security perspective. Important benefits for multi-tenant are consolidation and manageability. You can consolidate multiple databases into one for better resource utilization and cost optimization. Fewer database patching and upgrades is one of the benefits. It's easier to apply a patch to one database than to apply to 100 databases. And also to upgrade one database over upgrading 100 separate databases. With RDS Custom for Oracle Multi-Tenant, you can create up to 252 user-created PDBs in a single instance. With support for Oracle Multi-Tenant, you can now run Oracle e-Business Suite versions 12.1 and 12.2 against an Amazon RDS Custom 19C database instance with a single PDB. Let's look at some other notable features for RDS Custom for Oracle. On the manageability side of things, RDS Custom for Oracle is now available in 2 more regions, that are Canada Central and Sao Paulo. We also now support promotion of managed in-region read replica. Along with these features, there is a way for customizing Oracle Home through parameters in manifest file of RDS custom for Oracle while CEV creation. These parameters include Oracle Base, Oracle Home, install Unix user, install Unix group, and their IDs. Under performance and scalability, one of the awaited features for RDS custom for Oracle is now available, and that is ability to scale compute capacity up or down. With that, we are at the end of this session. In the comment sections, please let us know if you have any feedback for the information presented in this video. Thank you so much for watching.